Hello, my name is Subramaniam Balakrishna, and I am a graduate student at the Mechanical Engineering Department at the University of Michigan. Today, I'm going to talk to you about sticky business, or the science of saliva. Whenever we're sick, a visit to the doctor's clinic often requires the doctor to draw blood, run a test, and write up a prescription. Because no pain, no gain, right? What if I told you that you could be diagnosed for HIV, Parkinson's, or a whole host of other diseases without having to stick a needle in you? Yep, you heard right. The secret behind all of this is saliva. So what is saliva? The image that often comes to mind is that of drooling babies who seem to possess an infinite amount. However, the important thing is that saliva aids in chewing, yes, even in this case, swallowing, healing, and lubricating, in addition to a whole host of functions. Saliva consists of 99.5% water with some little bit of proteins and some other constituents. One way to think of proteins in this regard is a network of masses connected by tiny springs. These proteins are what cause saliva to behave neither like a fluid or a solid. The behavior that saliva shows, which is intermediate to that of a fluid and a solid, is termed a non-Newtonian fluid, named after Sir Isaac Newton. One example of non-Newtonian fluids that you might have seen, aside from saliva, is that of cornstarch and water. Now, if you have a large amount of cornstarch and water, you can run over it without falling into it. Or if you have just a little bit, you can splash it on yourself, just like a fluid. Now, because these materials show behavior of both solids and fluids, they become interesting to classify. The term sticky saliva is used by health professionals to describe not so normal saliva behavior. Now, as a non-Newtonian fluid, my goal is to classify the not so normal behavior of saliva. So how do we quantify this? The three parameters we can look at are surface tension, which is the force that helps us blow bubbles. The second one is viscosity, or the resistance of fluid to its own flow. Some might even call it fluid friction, as you can see in this example with honey. Another example of a property that's important is elasticity, or rubberiness. Think of the object returning to its original shape in this context, along with resisting change. Now, so all we require at the moment are quantifying surface tension, viscosity, and elasticity of saliva. Well, some things are easier said than done. To paraphrase Peter Parker, with great power comes great problems. Surface tension, viscosity, and elasticity of saliva change based on time of day, the time at which the sample is removed from your mouth, in addition to a whole host of other factors. Also, a drop of saliva evaporates very quickly. Poof, just like so. So small samples need to be studied really quickly. So how do we do this? Previous research shows that you have to A, pull the sample, B, monitor the diameter of the sample, and C, plug the diameter values into a formula. This method is termed capillary breakup rheometry, or CBR. However, traditional analysis from CBR are valid only when the filament is really close to breaking up. Close to breakup, the filament may be as thin as a human hair. There's a figure for comparison. So what do we do now? This is where we come in. Our preliminary analysis to determine the surface tension to viscosity ratio makes minimal assumptions. In addition to it, our new formulas work well before breakup as long as the filament continues to evolve. However, funky things, like this one right here, term beads in a string, may be observed. This messes up with using our equation in order to measure the surface tension to viscosity ratio. So our goal now is to find the sweet spot, or the right way to A, pull the filament, because we can now pull it any way we like and try to understand what's going on, but B, to avoid these funky things like beads in a string. So essentially looking for a sweet spot for measurements. Armed with this new formula and the way we're supposed to pull the filament, we should be able to quantify your saliva. Hopefully, you'll see this apparatus in a clinic near you sometime in the not so near future, or maybe even closer. Thank you.